All right, so make sure you have with you this worksheet, the steps to factoring, and also the worksheet on, for those in Math 140 class, it's gonna be chapter 6B worksheet. This one right here, the one that we went over on Wednesday, chapter 6B, this is factoring. And for those of you guys that are in my Math 140 or Math 130 class, yours would be chapter 3B, I'm sorry, chapter 4B, factoring for those in Math 130. So again, this chat room is consisting of Math 130 and Math 140 folks. All right, let me make a few announcements. No, I'll make the announcements later. No, I'll make the announcements now. First thing is what to expect for today. One, I'll be going over the lecture for chapter 6B. Two, I just want to emphasize that I did change what used to be 36 topics is now just 29 topics. So I already made that change on Alex, so it's a fewer topics for you guys. This chapter is due on Thursday. If for any reason, if you guys need an extension or so, make sure you message me either through Facebook or on email or whatnot, or on Canvas to ask for a 1 or 2 day extension. Just don't fall too behind. And then as for the quiz, I'll talk about the quiz in a second, okay? Any questions right now? If you have a question, just unmute yourself. All right, so we left off on Wednesday with question number 13. So question number 13 is where we left off, and actually someone had a question on number 13 on factoring a trinomial. So I'm going to first show you a video that I did just to review factoring a trinomial, and then I'm going to go over questions number 14 all the way to question number 19, which is to factor 2 terms. And then I'm going to do a live lecture on questions 20 through 24. So I will turn on my screen sharing at this time. And if any of you guys need to leave at any time, feel free to do so and just watch the recording later, but the recording takes a little bit of time. All right. So I'm going to show you a video of factoring a trinomial that someone had a question on how to factor a trinomial. And so it's a review of what we did on Monday. Hi everyone, this is Professor Mahan. This video is for my Math 130 and Math 140 class. I'm so glad to have you guys here. Today we're going to continue on with the topic of factoring. So we had discussed factoring on Monday, and most of you guys showed up, which is great, but I know there were a few of you guys that couldn't. So hopefully you guys got caught up on the material. Real quick, here it is. This is a summary of what factoring is about. So on Monday, we went over how to find the GCF, the greatest common factor. And the greatest common factor, one of the things we always need to keep in mind is that we want to make sure that we factor it to death, meaning we factor it completely all the way. So just because you factored it once after finding the GCF doesn't mean that it's done, so you got to keep going. Okay, and then after we learned how to find the GCF, then we learned how to group. So whenever you have 4 terms, you want to make sure that you group it in order to factor it. And then we also learned if you had 3 terms, then you do the Xbox method, or whatever method that you choose. But I chose to teach a class how to do it using the Xbox method. And today we're going to learn about what would you do if you had 2 terms. So if you had 2 terms, then you have two options of formulas that you need to choose from. So before we go into the 2 terms, one of your classmates had a question about solving factoring using the Xbox method. So I'm going to do a quick video on that right now. All right, so using my ghetto fabulous whiteboard, let's talk about how do you factor this polynomial here. So first you want to do is you want to count how many terms there are so you could know which direction to go with that factor man that I showed you guys earlier. So remember, term is separated by adding subtraction signs. So there's 1 term, 2 term, and 3 terms. So this is 3 terms. And when it's 3 terms, we call this a trinomial because the root word is tri, which means 3, trinomial. And if you looked at that factor man that I showed you earlier, if it's a trinomial, you want to make sure that you use the Xbox method. So we want to use the Xbox method with trinomials. But before we do that, we always want to make sure to see if there's a GCF. So here, 7y squared, 13, and 6, I ask myself, the 7, 13, and 6, is there anything that's divisible by 7, 13, and 6? And the answer is no, nothing's divisible by that. There's y squared, y, and there's no y here, so there's no greatest common factor. These 3 terms don't have anything in common that can be divided by it. So we leave it as that. So I'm done finding the GCF, which there's none. So now I'm going to go down to doing the Xbox method. So again, just reminding you guys that the Xbox method is just one method to factor a trinomial. There's many methods. On Alex will teach you a certain way. Maybe another teacher will teach you a certain way. Maybe, online it might teach you a certain way. But the Xbox method is my favorite way of doing it because it works for the easy problems, the hard problems, the multivariable problems. It works for all of the problems. So I'm just going to stick to teaching one method and try it out. And if you don't like it and you like the other way that you learned it from another teacher or whatnot, feel free to do whatever works for you. But check this out and see if you like it this way. The first thing I do is I make sure that it's written in standard form. So written in standard form means that it's written from the highest exponent to lowest. So it's written in order from the highest exponent to lowest. So here is y squared, y, and then there's no exponent. So this is indeed in standard form, so I don't have to do anything about it. For those of you guys that are working on Alex, the nice thing about Alex is it's always written in standard form. When they give you the problem, they'll always have it in standard form, so you actually won't have to change anything about it. But just in case you get another textbook or another teacher that mixes up the order, then you want to make sure you write it in the correct order first. The second step is you are going to look, those are eyeballs, look at the first and third term. And you're going to write down, right, 2 terms, or let me say, write 2 things, I'll just write things, 2 things that multiply to give you the first and third terms. So this sounds more confusing than what it is. So I'm going to look at the first term and the last term, and I'm going to ask myself, hey, what 2 things multiply to give me 7y squared? Well, what 2 things multiply to give me 7y squared would be 7y and y, right? That's the only option. Now, what 2 things multiply to give me 6? Well, there's lots of things that multiply to give me 6. There's 1 and 6. There's 6 and 1. There's 2 and 3, and 3 and 2. Right, so there's a couple options. So let me just try one of the options. Let me try something that I know. Let's try 1 and 6. Okay, so 1 times 6 will give me 6. And I also know in mind there's other options. So if this doesn't work, I'm going to try the other options. All right, then the next step, after I do that, is I'm going to cross multiply. So in other words, this is where the word x comes from. The word Xbox for this method. So I'm going to cross multiply. So when I cross multiply, I'm going to get 7y times 6, which will give me 42y, and then y times 1, which will give me y. And I'm going to ask myself, when I cross multiply, does this add or subtract to give me the second term? So that's what you want to be thinking in your head. So you might be wondering, what is this guy good for? What's this middle term good for? Well, this this negative 13y is really important because it's going to tell you whether you chose the right numbers or not. So what I'm going to do is I'm going to look at these two. When I cross multiply, I got 42y and y. So can I add or subtract these numbers to give me a negative 13y? Well, if I add, I get 43y. If I subtract, I get 41y. So the answer is nope, no. So those numbers do not work. So I should have gotten an eraser somewhere. Okay, here's some. Sorry. Again, excuse the ghetto fabulous video. So these numbers do not work, so I'm going to erase it. So 1 and 6 does not work. So I'm going to try something else. How about if I switch the order? What if I try 6 and 1, right? And again, if that doesn't work, then I'll try 2 and 3, because 2 times 3 is 6. But anyways, I'm going to try 6 and 1. So when I try 6 and 1, when I cross multiply, I get 7y and 6y. And I'm going to ask myself, is there any way that I can combine these to get a negative 13y? Can I add or subtract these numbers to get a negative 13y? And guess what? What do you think? All right, no response. So here, I'm going to do a negative and a negative. If I have a negative 7y and a negative 6y, I will indeed, if I add those two together, I get a negative 13y, which is what I wanted. So I know that these are the winner chicken dinner answers. So woohoo, these are the right answers. But however, I need a negative here and a negative here. So how do you make these negative? Well, to make a negative 7y, you need 7y times a negative 1 will give me a negative 7y. And y times 6, I want it to be a negative 6y, so I'm going to put a negative 6. But I need to be really careful at this point because I really need to make sure that when I put these negatives, I need to make sure that if I multiply these two numbers, will I still get the number, the third term? And the answer is yes, thankfully. Negative 6 times negative 1 does give me a positive 6. So that does work. So those are my winner chicken dinner numbers. So that's the part for X. Now the last part is the box. So what is box? So the box is when you box up your answer. So you box this up horizontally. So I draw those two boxes. So the problem 7y squared minus 13y plus 6, when I factor it, so factoring means writing it as a product of two or more polynomials. So when you write it as a product of two more things, the first thing that goes in the first box is this right here. The first box, the first horizontal box, 7y minus 6. And then the thing that goes in the second parentheses is the box below, which is y minus 1. So boxing it helps you to remember that you're writing your answers horizontally, like that. So this is the answer when you factor. And the very last step, which I encourage you to do, especially if you're doing a test or a quiz, is to make sure to check your answer. And how do you check your answer? Well, you check your answer simply by multiplying through. So remember, factoring is reverse of distribution. So if you want to check your answer, you just distribute. So distribute your answer. Sorry, I should have turned off my phone there. If I distribute my answer, meaning FOIL it, I'm going to get 7y squared minus 7y minus 6y plus 6. In other words, 7y squared, I combine my terms, which are these two, negative 13y plus 6. And holy smokers, that is exactly the same thing as that. So this indeed is the correct answer for factoring. Alrighty, so I'm gonna unmute everyone real quick. And how do you unmute? Gosh, unmute all. Right. Anyone have any questions with what we just did for Xbox? That was kind of a review. Jennifer, did you have a question? I see your hand up.
Yeah.
Jennifer, did you have a question?
Oh no.
No, okay, I just saw your hand up there. Okay, I'm gonna put your hand. Does anyone have any questions? There's a thing on the side where you could raise up your hand, and then I'll know that I can unmute you. Any questions on Xboxing?
No,
all right, so if not, we're gonna keep continuing on, and welcome to the rest of you guys that have joined aboard. Now we're at 32 of you guys. So the next thing that I'm going to do right now is I am going to move on to the second part, which is a new part about the difference of two squares. So go ahead and follow along. And a reminder, Math 140 students and Math 130, you're going through the exact same thing, but the problems on each of your worksheets are a little bit different, but they're basically the same types of problems. So let me put this on real quick. Sorry, I just lost it. Okay. I'm going to screen share and put on the next video, and I'm going to mute everyone. Your dog and all that. Such fun background noise. All right, I've muted everyone at this point, and I am going to mute them. All right, now I'm going to screen share. Okay, I'm going to screen share my next video, which is on the difference of two squares. Alrighty, hi everyone. Back to me again, and now we're going to start looking at what do you do when there are two terms. And again, if you looked at that worksheet that I gave you guys, is if you have two terms here, we are going to do something that says square terms and something that says cube terms. So there's some blanks here, and I'm going to fill in the blanks with you guys. So dots stands for an acronym for difference of two squares, and I forgot the word two, so make sure you write that in. So dots is the difference of two squares. So if they're asking you to factor something, and they say to factor something and it's in the form of something squared minus something squared, then you're going to factor it using a certain formula that I'm going to show you in a second. These are for cube terms. So they're asking you to factor something that's in the form where something is being cubed minus something is being cubed. You're going to use this particular formula, or something being cubed plus something else being cubed, then you use another formula. So this would be called the difference of two cubes or the sum of two cubes. And because I'm kind of cheesy like that, I made the acronym DOCTICA, D-O-T-C, and the acronym SOCTICA, S-O-T-C. So whenever I get two terms, I ask myself, is it a dots, a DOCTICA, or a SOCTICA? So whichever one it is, then I'm going to use that formula. So let's talk about those formulas and how to use them. All right, so let's talk about dots first. So dots, D-O-T-S, so maybe I'll just write it right here somewhere. Dots stands for difference of two squares. So D-O-T-E-S or D-O-T-S. And again, I'm making up this acronym, so you might not see this in a math book or anything, but it's just something that I use to remember something. So if you're given, so this is what you're given. If you're given something in which you have two terms, such as these problems here, you have two terms, and they are in the form where something is being squared minus something else is being squared, then this equals to, when you factor it, it's going to be equal to A minus B times A plus B. This is the factored version. This is the factored version of this polynomial. So again, factor means that you're writing something is as a product of two or more things. So before we do this example, I just want to ask us, where did they come up with this formula? Did it just come out of thin air, or did it require a genius like Einstein to figure out this formula? Well, the answer is no. It doesn't require genius to figure it out. So let me talk about how this formula came about. So remember, factoring is just the reverse of distribution. So if we were given A minus B times A plus B, if I gave that to you initially, we know from the past few weeks with mathematics, how you solve this is that you would just distribute it. So if you distributed it, meaning you spoil or just distribute through like that, you would get A squared plus AB, right? And then you would distribute the bottom, so you get minus AB minus AB minus B squared. So when you do that, and then you combine like terms, AB and AB here are the same terms. It's plus AB minus AB, so you end up just getting 0. So you end up just getting A squared minus B squared. So it didn't require Einstein or a genius to figure this out, right? So again, if you have something in the form A squared minus B squared, to go reverse, which is what factoring is the reverse of distribution. When you go reverse of this, it's A minus B times A plus B. So that ends up just always being a pattern. So because it's a pattern, we created a formula for it so it's easy to use. So here it is. This is equal to that. All right, so let's look at the first problem here. First problem is W squared minus 36. First thing I ask myself is there a GCF? So remember, when we're dealing with this, the first thing we want to ask ourselves, actually use the wrong form, this right here, find the GCF. So the first thing you want to do is, the guy says, or the girl says, find the greatest common factor. W squared and 36. Do they have anything in common? No, it doesn't. So no GCF. So that doesn't mean that we stop there. We can still keep factoring. So even though there's no GCF, we can still keep going. There are two terms. Okay, two terms. What do I do? Do I do X box? No. Do I group? No. Two terms. Is it a dots, a doctica, or soptica? So in this case, this is a dots. It's a difference of two squares, and I'll show you why it's a dots. So a dots is something that's in the form of this. It's the difference, meaning subtraction, of two squared things. And notice it's squared and squared. So when we look at this, I ask myself, is this a dots? Is this the difference of two things? Is it the difference of two things that are squared? So here, when I look at W squared, is this term the squared of something? The answer is yes. This term W squared is the squared of W, right? W is being squared to give me W squared. Minus 36, is 36 a squared term? Is something being squared to give me 36? And the answer is yes, it is the number 6. 6 squared gives me 36. So therefore, since it meets this criteria, then yes, it is a dots. And because it's a dots, I can factor it using this formula. So the formula says A squared minus B squared equals to A minus B, A plus B. Well, this is kind of like my A, and this is like my B in the formula, right? So when I factor it, when I write this as a product of two different things, the first one is going to be A minus B. Well, A is W and B is 6. So W minus 6. And then the second one is going to be A plus B, which is W plus 6. And this is our final answer. Was that easy or what, right? And I always recommend checking your work. So again, if you check your work, if you FOIL this, just like we did here, if you FOIL this, you would get W squared plus 6W minus 6W minus 36. The two middle terms cancels out, and we end up getting W squared minus 36. And what do you know? That was what we first started off with. Okay. So, and maybe some of you guys might ask, well, does it matter which way you write this order? And the answer is, no, it doesn't matter. So it could be A minus B times A plus B, or you could write it as A plus B times A minus B, and that's A-okay. So it doesn't have to be the minus first, it could be A plus B times A minus B. So this answer is also acceptable if you put W plus 6 times W minus 6. Both answers are acceptable. All right, so let's take a look at another problem. So this problem here is number 15 on the Math 140 worksheet. And for those who are in Math 130 worksheet, it's something very similar to this, so you could do that extra problem as well. So here again, the first thing I ask myself is there a GCF? Does 81x squared and negative 4 have anything in common? No, it doesn't, right? So now that it doesn't have anything in common, then I'm going to count the terms. Uno, dos. two terms. So I am not going to Xbox. I am not going to group. I'm going to look at this two terms where I ask myself, is it a dots, a doctica, or a soctica? Well, I'm going to try to see if it's a dots. So is it a dots? In other words, is it the difference of two square terms? The difference, meaning subtraction, of two square terms. Well, I look at 81x squared. 81, is it a square term? Yes, it is. What squared gives you 81? 9. X squared, is that a square term? Yes, it is. It's the square root of x. So 9x, if I square that, gives me 81x squared. So that works. That's a square term. The second blank is for a square term. Yes, it is. It's the square root of 2. So yes, it is a difference of two squares. So because it is a difference of two squares, I can now use this formula. So when I use that formula, what this equals to, when I factor it, so this is factoring now. When I factor it, it's going to be the product of two things. And the product of those two things is a minus b times a plus b. And here, okay, my knees are hurting. Okay, so here is my a, and here is my b, right? So a minus b times a plus b, so I'm going to get 9x minus 2, a minus b, times the second parentheses, a plus b, 9x plus 2. And again, you could write this in reverse order. You could write this as 9x plus 2 times 9x minus 2. So either one would be a-okay. Okay. And again, you could check it by distributing and foiling it out, and you'll see that you'll end up with that answer. So I highly recommend doing that, but for the sake of time, I'll let you guys check it on your own. All right, last but not least is this being recorded? Yes. Last but not least is number 16 on the Math 140 worksheet, or number 16 on Math 130 worksheet. Again, another type of problem like this. So again, I'm going to ask myself, does this have a GCF? And maybe at this point you're like, oh my gosh, everything I've been doing does not have a GCF. Why do I keep going through this? Well, check this out. Here I have two terms. Does this have a GCF? 49 and 81. Actually, it doesn't. Okay, wrong problem. Maybe in a future problem I'll get to, it will have a GCF. But for now, these three problems did not have GCF. So the answer is no. So now I see two terms, so I'm going to ask myself, is it a dots? So is it the difference of two squared terms? So the number 49, what squares to give you 49? 7. U squared, what squares to give you u squared? U. Minus 81v squared, what squares to give you 81v squared? 9v. 9v times 9v is 81v squared. So hopefully I'm going a little bit faster now that you're able to catch on with it. So here, I'm going to write this now as the product of two or more items, and this is the step of factoring. So using this formula again, it's going to be a minus b times a plus b. This is my a, and this is my b. So it's going to be 7u minus 9v and 7u plus 9v. And that is your final answer for how to factor a dots problem. Alrighty. At this time, I'm going to unmute you guys to see if any of you guys have any questions on what we've done so far. Anyone have any questions at all?
Instructor, the videos that you just showed us, will you also be uploading that on Canvas or Facebook?
Yep, I'll upload everything on Canvas and on Facebook and on YouTube, so there'll be multiple places. I'll put it all in there.
Thank you.
Any other questions? All right. Hi. Uh-oh, I think my kids are home. Oh no, it's not. It's my roommate. Okay. Hey, Cora. I'm doing a conference call with my students. All right, so the next video I'm going to do right now is about the difference of two cubes and the sum of two cubes. So I'm going to mute you guys on this as well. And actually, this is a longer video, so I'm going to actually cut it a little bit short because the beginning is another problem of the difference of two squares. So I'm going to cut it down a little bit shorter to make, but if you guys want to see the long version, you can click on it. I'm going to show it on YouTube later or put it on Canvas. All right, so I'm going to mute all of you guys right now. So mute all. And I'm going to screen share. And we're going to look at this video here. All right, hi everyone. Now we're going to go on to how do you factor with using difference of two cubes and sum of two cubes. We just covered difference of two squares. So again, going back to this factor man or factor.
I can't hear anything.
I have no audio for your video.
Hello, instructor? I'm not sure if it's just me, but I'm not able to hear the video at all.
No, I can't hear it either.
Can you guys hear it now?
This formula here. And I showed
Okay,
you
yes, I can hear it now.
Okay, sorry about that.
Just come out of thin air, nor does it take Einstein to figure that out. You just multiply through and we end up getting that. The difference of two cubes, again, I just love mathematics because the name of the method really describes what it is. So you don't have to like memorize words that make no sense, right? So the difference of two cubes, meaning you have two cube terms, right? The cube, that's why there's a 3 on them, and it's a difference. So you subtract. So if a problem, say one of these problems, falls in this category, the difference of two cubes, then the formula would be a minus b. Okay, so it's a long formula, just warning you. A minus b, then a squared plus ab plus b squared. And yes, you're required to memorize it, right? So it's going to be this here. And again, how did they come up with this? Well, if you multiply this through and you do all the distribution, you will end up with that. And for the sake of time, I'm not going to show you that proof, but you could just check it on your own time if you would like. Now the sum of two cubes, so again, 2 cubes, so a cubed, b cubed, and you're going to do the sum of it, and the sum means addition. So a cubed plus b cubed, the formula. So the nice thing is the formula looks just like the one on top, just with a few minor changes. So instead of a minus b, you're going to do a plus b, which is nice because this was a sum, right? A plus b. And then it's going to be exactly the same thing on top, except you're just going to change that sign to a minus. So this is a plus here, then this becomes a minus here. Similarly, if this is a minus here, then this becomes a plus here, just to help you memorize it. So these are the 3 formulas, really important formulas for you to know to do this problem. To do these problems. And actually, I am going to change this to a plus here, just to, because I notice all of these are on minus, I'm going to change that to a plus. All right, so let's look at number 17 here. So 17 here, first I ask myself, is there a GCF? So is there a GCF here? 48 and 27. This is an odd number, this is an even. So right now they don't have anything in common off the top of my head. So the answer is no. And I see there's a z cubed and a z. Actually, I just thought of something. 48 and 27 does have a common GCF of the number 3. So yes, 3 is a GCF because 48 divides by 3 evenly, and then 27 divides by 3 as well. So great. And then there's a z cubed and a z. Okay, they both have a z in common. So we talked about this on the first lecture about how to find the GCF. So if you need to review that, please feel free. So z, so they both have a z in common. So right now I'm going to rewrite this with the GCF on the outside, right? So the GCF is on the outside. I pull out the GCF, and then I'm going to write down what's inside. And of course, the inside, since there's 2 terms, there's also 2 terms here. So 3z times what will give me 48z cubed? So 3 times what will give me 48? Or in other words, what's 48 divided by 3? And the answer is 16, right? So 16 times 3 will give me 48. Z times what will give me z cubed? Z times what will give me z cubed? Well, this is a 1 here. Then using the product rule, you need to add the exponents. So we add exponents, 1 plus 2 will give you 3. So again, if you're kind of weak on that, make sure you go back to the previous section on exponential rules so that you can get good at doing that. The second one here is 3 times what will give me 27? Or in other words, 27 divided by 3 will give me 9. And then since there's already a z here, I don't need to put a z there. And I always take this moment to double check my work because I tend to make minor mistakes by just distributing through it to make sure I get the original. So 3 times 16 gives me 48. Z times z squared gives me z cubed. 3z times negative 9 is negative 27z. Perfect. Am I done? I just factor, right? Am I done? And the answer is no. Because this dude says factor me to death or factor completely. So factor all the way. So when I look in here, I'm like, can I still factor this? Well, let's check. There's 2 terms. Okay, 2 terms. What do I do? It's either a dot, doctica, or soctica. Well, which one is it? Well, this is a minus. So since it's a minus, I know it's going to be a difference, right? So that takes out the sum of 2 cubes. It's not that one. So it's either the difference of 2 squares or the difference of 2 cubes. Well, I see here z squared. Z squared tells me, oh, maybe it's a square term because it's z squared, right? So maybe it's a square term. So I asked myself, I have a hunch that this might be a square term. So if it was a square term, what is being squared? So what is being squared if this is a dot? So is this a dot? And if it is, then what is being squared? Sorry, this is so ghetto. Okay, so what is being squared? So here, 16z squared, well, what's being squared? 4z is being squared. What is being squared for 9? 3 is being squared. So because of that, I know, yes, it is a dot. So therefore, I could use that formula, 4z minus 3 times 4z plus 3. So here, I'm going to have, so when I factor, so this is my factoring step, right? This is just me double checking if this is a dot. And if it is, then I'm going to write it in the factored form, 4z minus 3, 4z plus 3. Is that my final answer? Am I missing something? Yeah, I hope so. I hope you said yes, because what I'm missing is I'm missing the 3z. So the 3z also goes outside here, and your final answer would be this. Okay. All right, next problem. This one here. So the first thing I'm going to do is there a GCF? So I hope I'm sounding like a broken record. I feel like I am, but that's the nice thing about math. It just repeats itself, right? There's nothing new and crazy about it. So I have 2 terms. What do they both have in common? They both have a 2.
So I'm going to forward this a little bit. Let's see.
5.
Okay, I'm going to forward it so that it goes to the section about
8u cubed minus
okay, here you go.
125. So again, 2 terms. Is there a GCF? The answer is no, right? 8 and 125 do not have anything that's divisible by both. And this is a u cubed and this doesn't. So there's no. Okay, that's fine, no GCF. So now I see 2 terms. So because it's 2 terms, I'm gonna go down the body to say, is it a dots, a doctica, or a soptica? So here, 2 terms, and I see a subtraction sign. Subtraction means it's a difference. So I'm gonna knock out the option of it being a sum. So it's either a dot or a doctica. So it's a difference of 2 squares or a difference of 2 cubes. So when I look at this, I see u to the 3rd power. Well, u to the 3rd power is a cube exponent, cubic exponent. So I have a hunch that's gonna be a doctica, a difference of 2 cubes. So doctica, that's how I write that. And this is soptica, and this is dots. So I have a hunch it's going to be a doctica. So, a doctica is in the form where something cubed minus something cubed. So my question is this a doctica? Is it the difference of 2 cubes? All right, so when I look at 8u cubed, what's being cubed? So the number 8, what number cubed will give me the number 8? And the answer is 2. 2 times 2 times 2 will give me 8. U cubed, what's being cubed? The u. 125, what is being cubed to give me 125? 5. Awesome. So yes, it is a doctica. So because it's a doctica, I'm going to use this nifty formula here. So when I use this nifty formula, I'm just going to plug it in, right? So here, it's going to be something multiplied by something else, right? And it's going to be a minus b, right? So I'm just going to write it below here, a minus b multiplied by a squared plus ab plus b squared. Well, what is my a? This is my a. What is my b? This is my b. So a minus b, to write that, a minus b is 2u minus 5. A squared, what's a squared? What's 2u being squared? So 2u times 2u gives me 4u squared. Plus a times b, so 2u times 5 gives me 10u plus b squared. So b is 5, so when I square that, I get 25. And that, my friends, is the final answer. So it's not too hard in the sense where the formula is already given to you and all you do is you just plug it into the formula and then get it. It's just a hard part is actually memorizing the formula, right? But the more and more you do this, the more easier it'll get. Here's the last problem we'll do on this. 8y cubed plus 27, first off, is there a GCF? So 8 and 27, nope. Y cubed and nothing, nope. So no GCF. So then I ask myself, since there's two terms, is it a dot, a doctica, or softica? Well, it's an addition sign. So because it's an addition sign, I'm pretty sure I'm going to check that's going to be a sum of two cubes. So my hunch is that, is it a softica? Is it a sum of two cubes? So in other words, is it the sum, addition of two things being cubed? Here's a cube. Sorry. Yeah. Okay. Is it the sum of two things being cubed? So let's check. 8y cubed. What is being cubed to get me 8y cubed? 8y. 27. What is being cubed to give me the number 27? 3. Awesome. So it is a softica. So because it's
Okay, real quick, I just noticed I made a mistake. It's not supposed to be 8y. It's supposed to be 2y. So 2y. Okay, so teachers make mistakes as well.
softica, I am going to use the formula for softica, which is this. And that formula is it's a plus b times a squared minus ab plus b squared. That's the formula that I'm going to use to factor it. So here, when I do this problem, I'm going to get a plus b. So this is my a and this is my b. Right? This is my a and this is my b. So a plus b is 8y plus 3.
Should be 2y plus
A
3.
squared, so 8y being squared is 64y squared.
So again, it should be 4y
minus a times b, 8y times 3 is 24y. And then plus b squared, so 3 times 3 is 9. Ta-da! And that, my friends, is how you factor two terms using dots, doctica, or softica.
Okay, sorry guys. So make sure that this is actually a 2y because 2 cubed gives you 8, not 8 cubed. So therefore, this should be a 2y plus 3. This one here should be a 4y squared. And this one should be 12y. So get rid of that. Alrighty, let's get back to us. So let me unmute us to see if any of you guys have any questions. Okay, how do you unmute? Unmute all. All right, do any of you guys have any questions on what just happened right here?
For the last question, where did you get negative 24y?
Oh, I did that wrong. That last question. That last question, it should not be negative 24y.
I got the answer 2y plus 3 times 4y squared minus 6y plus 9. Is that the correct answer?
It should be 6y, exactly. It should
Okay.
be, can you say that again one more time?
Oh, okay. I got, what was it, 2y plus 3, what was it, times 4y squared minus 6y plus 9.
Perfect. Can you show that one more time, Alexis? Can you just speak and then just put it on the screen so people can see it?
Yeah, of course. That's the right way. Okay.
All right, thank you, Alexis. So again, I made a mistake on that, human error. Thank you for catching that. Does anyone else have any questions on any of this? Does anyone have any questions on what Alexis just did?
No.
Okay. All right. So, and you know what, you guys, this is my first time doing this, and I'm just doing lecture, and please give me feedback. Feel free to email me or message me or even tell me over the ConferZoom at the end if you guys want me to change it up in any way, or I'm more than happy to just pause and stop and let you guys work on the problems and different things. But I guess this is my first time, so I'm just trying to make the videos. But next time, I promise I'm going to make it more interactive, so you guys are doing stuff and speaking as well. I'm going to take a quick, just a quick pause. Group 1 for Math 130 and, I'm sorry, Group 2, 2 for Math 130 and Group 2 for Math 140. Are you guys here? And are you guys ready to do your presentation?
Yeah, it's me, Cassidy, and Lakonda. Daniel can't be here because I guess he got called into work.
Okay. And Cassidy and Lakonda, did you guys want to screen share, or how did you guys want to do this?
Are they here?
I see Cassidy. Lakonda, are you there? Cassidy, are you in my Math 130 or 140 class?
We should have closed it already. I'm leaving.
Cassidy, can you hear me?
I think they said that their like audio or something is messing up, so they keep like leaving the conversation and then coming back to see if it works.
Okay, well, I'll just keep going forward.
Okay.
So once any of those groups are ready to present, let me know and I'll put you guys on.
Okay.
So let me know, okay? Just raise your hand or whatnot.
Okay.
How about Group 2 for the other class? Are you guys ready to present or not yet?
I think I'm the only one here, so
Okay.
yeah. I don't know how to share the screen though. Can I send it to you and you can share it from your side?
You know what? You could press share screen. Is this Hida?
Yeah.
Okay, Hida, you can press share screen on the bottom.
Let me get it first. Can you give me some time?
Sure. Okay, so why don't you just get that ready?
Okay.
And while you're getting that ready, I'm going to do the lecture here. While you're getting that ready, I am going to do I'm going to do the lecture on the, what time is it? It's 2 o'clock. So I'm going to do the lecture on this last section, which is on solving equations. So numbers 20 all the way to number 24. I'm just going to do 2 problems to get you guys started on how do you solve equations with quadratics in it. So,
Sure.
So once any of the groups are ready to once I'm done with this, then you guys can set up. So I'm going to mute you guys for now so we can continue on with the lecture. All right. right, and this is a live one. This is not pre-recorded. So, here's my markers. And my kids might run in at any moment because their dad is dropping them off at 1:30 or 2 or something. So, how do you solve quadratics? If you look at the back of the sheet right here, everything that I wrote here is basically the words for this one, right? Where it says factor out the GCF if it exists. Step 2 is count the number of terms. If it's a binomial, these are what you do. Dots, doctica, soctica. If it's a trinomial, then use Xbox method or your preferred method. And if it's 4 terms, you want to group, right? So it's basically the words for this picture. So I have the picture, but then you have the words as well. Now, if you guys recall, one of the things I had, let me reduce this down real quick. How do I, dun, dun, dun. Whoops. Okay. So if you guys recall, I mentioned that factoring is just like the working out part, right? It's not really the goal of mathematics just to factor. We're going to use factoring for some reason. So what we're using factoring for is to solve quadratic equations. So this is a new word, quadratic equations. Now, what in the world is a quadratic equation? So thus far, we've worked with linear equations. So when we solved linear equations, we've solved things such as 3x plus 4 is equal to 7 or something like that. We solved this in the beginning of this semester. And notice that the highest exponent is the number 1. Whenever you're dealing with a linear equation, and a linear equation is something we draw, it becomes a line, the highest exponent is just 1. And it just looks like a line if you were to draw it. So that's a linear equation. But now, if you remember, I mentioned that this is now where we go into 2 roads, right? Those who know how to factor and those who don't. And the reason why it's a second road now is because now we solve quadratic equations. And quadratic equations are very different from linear equations. Quadratic equations are these here. And notice when you look at these, what's the highest exponent? 2, right? The highest exponent is always 2. So when the highest exponent is 2, that's how you know it's a quadratic equation. And when it's a quadratic equation, then you're going to solve it a totally separate way from how you solve these. And actually, when you draw a quadratic equation, it's going to look like a parabola. And we're going to talk about graphing it in another chapter. But when you graph these, it's a parabola instead of a straight line. So how do you solve quadratic equations? One of those key things is to factor. So that's why it's really important to know how to factor in order to solve quadratic equations. So here, if you look at this, I have this thing that says steps for solving quadratic equations. And there are 4 steps, right? So let's talk about those 4 steps. 1, 2, 3, 4. Right. And here we are. Yay, right? So the first step is, where's my black marker? I think this is it. All right, so here it is. So the first step is going to be to rearrange so that the quadratic, so it says rearrange so that the quadratic is equal to 0. So rearrange so that, or I could just say the equation is equal to 0, right? So I'm writing it in shorthand, but you could write that down as step 1 here. Rearrange so that the equation is equal to 0. Notice in number 21, it's already equal to 0. Woohoo! Easy peasy. 23, it's not equal to 0 yet, so we need to rewrite it so that it equals to 0. So when I rewrite this, I have 4v squared, and I'm going to add the v to the other side. So I'm going to bring the v over there. So if I bring the v over, I get plus v is equal to 0. So now it equals to 0, right? Which is great. However, notice that this is not in standard form. You want to write it so that it's from the highest exponent to lowest. So I want to write it from highest exponent to lowest. I have 4v squared. The plus v, I'm going to make that a plus v on here, and then minus 3 is equal to 0. So that is step 1. Step 1 is to rewrite it in so that the equation is equal to 0. And I should put standard form. So I talked about standard form in the previous video. So standard form is from the highest exponent lowest. So now this is already equal to 0, so all good in the hood. And I'll talk about number 24 later because I don't have space. Okay, step 2 is to blank using the above steps for factoring polynomials. So step 2 here is a big F word, the other one, factor. So factor this using the steps that we did above. So here, 3y squared minus 21y, to factor, well, I'm going to first find out the GCF, right? So I'm going to find out the GCF, 3y squared and negative 21y. The GCF is 3y. So I'm going to go a little bit faster than the other videos, so assuming that at this point you guys kind of know how to do this part already. So 3y squared, 3y is a GCF. So here, there's two terms, so blank minus blank. What goes in those blanks? Well, 3y times what will give you 3y squared? Y. 3y times what will give you 21y? 7. And I always double check at this point, 3y times y is 3y squared. 3y times negative 7 is negative 21y. So I always double check. So factoring. Number 23, I also factor. But to factor, first I find out, is this a GCF? Is there a GCF? And the answer is no. Well, how many terms are there? 3. Well, if there's 3 terms, what do I do? Well, if there's 3 terms, what I do is I am going to Xbox. Yes, Xbox. So I'm going to say what 2 things multiply to give me 4v squared? So let's say 4v and v. What 2 things multiplies to give me a 3? Again, I'm going to ignore the negative. What 2 things give me a 3? Say a 3 and a 1. So I've done this so many times that I kind of know ahead which one are the right numbers. So for the sake of time, choosing the right numbers. But if you choose 1 and 3 or you switch it around, it'll take you more chances to do it. So here I'm going to X. So when I X, I get 4v and 3v. And then I ask myself, how can I get a 1v out of 4v and 3v? Easy. I'm going to subtract the 3v. If I subtract the 3v, then I will get a 1v, which is what I want. Well, to have a negative 3v, I'm going to have a negative right here. So 4v times 1 is 4v. V times negative 3 gives me negative 3v. And that's exactly what I want because I see that there's a negative 3 here. I knew that there was going to be a negative either in the first one or the second one. The question is which one. And it was this one. So a negative 3 times 1 gives me a negative 3v. So a negative 3. So these are my winner chicken dinner answers. So I'm going to box it. And when I box it, I end up getting, so here I'm going to erase this just for the sake of space. I end up getting 4v minus 3 times v plus 1 is equal to 0. Okay. So as you can see, step 2 can either be really fast or step 2 could be really long, depending on what you have to factor. So everything you've been learning about factoring comes into play here. So what do we do after that? Okay, sorry, my knees are hurting. I'm on the tile right now. Okay, so then the third step after you do that, so remember when you solve an equation, the goal is to find out what y equals to. The goal is to find out what v equals to, right? You want to solve it. You want to find out what v equals to and what y equals to. So step 3 here says apply the blank. So apply the blank. So step 3 is the zero product property. And I, in short, again, because I'm kind of cheesy like that, I call it the ZPP, yeah, you know me. If anyone remembers that song from way back then. The ZPP, it's called the OPP, yeah, you know me. So this is called zero product property. So the zero product property, what the zero product property says, so I'm going to erase. Okay, now I lost my eraser. Let me grab my napkin. And napkins are so precious right now, so I have to reuse it. So here, I'm going to erase this part. So I'm not using toilet paper, right? All right. So what the zero product property says, so the ZPP, this one's out of marker. The ZPP, zero product property, it says what it does. So zero product property, if I gave you A times B is equal to 0, right? If I give you A times B equals 0, that's a product property, and it equals to 0. What you can conclude is that either A must equal to 0 or B must equal to 0, right? A must equal to 0 or B must equal to 0, right? So the zero product property says if you multiply, if you have a product of 2 or more things and it equals to 0, that means that one of the factors, ding, 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 the word factors, one of the factors must equal to 0 in order for this to be true. So for an example, if I had 4 times x is equal to 0, right? What must x equal to? It has to equal to 0, right? In order for this to be a true statement. So it's called a zero product property. If you have a product of 2 things, so these are called factors here. If you have a product of 2 factors and it equals to 0, one of them has to be equal to 0 in order to make this true. If I made this a little bit more complicated, what if I said 4 times x minus 2 is equal to 0? If I have 4 times x minus 2 is equal to 0, I know that x minus 2 better equal to 0 in order to make this true. So if x minus 2 has to equal to 0, x minus 2 has to equal to 0 in order to make this true. So therefore, x is equal to, so what you do is you add 2 to the other side, you isolate the 2, or the x, so you get x is equal to 2. So you can solve for x using the zero product property. All right, so let's take a look at these problems here. So here, using the zero product property, step 3, I have 3y and times y minus 7 is equal to 0. So they're factored. So that's why we factored it, because now they're the product of 2 things and equals to 0. So once it gets to that point, I can now use my ZPP. So ZPP says that the factors, one of the factors or both, has to equal to 0 in order to make this true. So therefore, this is a factor and this is a factor, right? Factors are things that are being multiplied with each other, and that's why we factored. So therefore, 3y must equal to 0. Well, if 3y must equal to 0, let's solve for y. How do you get y to sit by itself? You divide both sides by 3. So you divide both sides by 3, you get y must equal to 0. This one, if I use the zero product property, y minus 7 must equal to 0, right? So these factors must equal to 0. One or both of them has to equal to 0 in order to make that true. So y minus 7 is equal to 0. I add 7 on both sides, so y is equal to 7. So therefore, in this problem here, you have 2 answers. In linear equations, you only had 1 answer, but a quadratic equation, notice the highest exponent is 2. So when the highest exponent is 2, you have 2 answers. So the answer is y is equal to 0 and y is equal to 7. And again, like all problems, the last step is to check your work. So if you look at this here, what I'm going to put here is if a times b equals to 0, then a equals to 0 or b equals to 0. Set each factor equal to 0 and then solve for your variable. I'll fill this out later and then I'll post this up so you have the written form, but I'm just saying it to you guys in words. And then the last step here is to check by plugging in your answer into the original equation. So if I plug 0 into here, I get 0 minus 0 equals to 0. Ba-dam. If I plug 7 into here, 7 times 7 is 49. 49 times 3 is some number. Minus 21 times 7, which is some number. If you subtract them, you will end up getting 0. I don't have my calculator in hand, but you could also check your work by plugging it in. All right, if you don't have any questions at this point, you can unmute yourself and ask me any questions, and then I'll go on to 23. Does that make sense? Angelica, did you have a question?
No, I'm good, thank you.
Okay. Anyone want to unmute themselves and ask anything? All good in the hood? All right, let me do number 23 now. I'm not sure what that sound is, so if you guys could mute yourself. So here I am going to, so I'm going to erase all this. I got space. And you know what? I realize as I'm doing this, like, I feel really tired of talking. So I think in the next conference Zoom session, I think what I'm going to do is change things up is I'll do a problem and then I'll have you guys do a problem and have you guys interact and show your work on the video. Okay. So bear with me for this one. It's kind of, I don't believe in someone lecturing for so long because if I were you guys, I'd be falling asleep, right? So bear with me for this one session where I'm just learning how to use a video, and then in the future I'll have it more interactive so you guys can talk and share and whatnot. All right, so with number 23, I have this times this equals to 0. We had factored in. Now I'm going to use the ZPP. So using the ZPP, I'm going to set this equal to 0 and set this equal to 0, right? So I set each factor equal to 0, and that's why it says here, set each factor to 0 and then solve for your variable. So I'm going to set each factor equal to 0. 4v minus 3 is equal to 0. V plus 1 is equal to 0. And now I can solve for it since now they look like linear equations. So I'm going to add 3 to both sides. And then I'm going to divide by 4 on both sides. I get v is equal to 3/4. So again, it could be a fraction. That's a-okay. Okay, and here I'm going to subtract 1 on both sides. So I get v equals to -1. And that's it, right? And again, you could check your work by plugging it in, and you should get, you should be able to solve for that. There's a pretty hard problem, number 24. It's really long, and just for the sake of time, I will not do it for now, but I will do it on a video to show you guys how to do it. It's the hardest problem, and I'll do it on a video so you guys could see what it is. The rest of this worksheet from 25 to 29 are word problems using the Pythagorean theorem. So the Pythagorean theorem, again, I have a video on that and I will show that as well. But I just wanted to give you guys the main idea of how to solve a quadratic equation. How do you do dots, doctica, and soctica? Let's see now. All right. I want to see your lovely faces now. I'm going to turn off the mute button. So unmute all. All right. Does anyone have any questions? Oh, my knee.
Perfect teacher.
If no one has questions right now, I'm going to ask group 1, or I'm sorry, group 2 for either class, Math 130, Math 140. Are any of you guys ready to share your presentation today?
I'll do it.
I'm sorry, who is it? Speaking?
I think it's me and Cassidy right now. I don't know if LaConda was able to.
Okay, is this Diana?
Yeah, and Cassidy. I
And
think
Cass-
she's here.
All right. And you guys are in my Math 130 class, right?
Yeah.
Okay. Go ahead and show, if you guys want to share your screen. Okay, I'm going to mute everyone except for Cassidy and Diana right now. So Diana, I just unmuted you, and Cassidy, I just unmuted you. And Cassidy, it looks like you're, okay, there you are. Are you guys ready to start?
Yeah.
So we did ours on how you can exchange currency. So it's really easy. The currency rates are always changing. So you want to make sure you're checking the currency exchange rate before you do all of the math. But you're just going to multiply the exchange rate by your desired outcome. And when you're coming back, you can always divide the amount of money you still have left by that original currency exchange rate. So we have a few examples. For the first one, we want to take US dollars and turn it into pesos. So when we did this, the exchange rate was 22.82. So if you want to exchange $500, you're going to multiply it by that 22.82, and that's going to give you 11,410 pesos. And then when you're coming back, you just want to go ahead and divide. So say you have 12,000 pesos, you're going to divide by that exchange rate again. You always want to round to the nearest tenth, and that's going to get 525 and 85 cents. And then we do have some examples for everyone else to do. And then I have the answer if you guys are ready. So if you have 11,510 pesos, you want to exchange it back to US dollars, you're just going to divide it by the current exchange rate. At this time, it was 22.82. And then you should get $504.38. We do have one more example with multiplying. If you have $1,200 in US dollars, you want to change it over to pesos, you're going to go ahead and multiply by that 22.82. And then everyone should go ahead and get 27,384. Yep, that's how you exchange currency.
Very cool. Thank you, Cassidy. Diana, were you there? I didn't even hear from you. Is Diana there?
I am not sure.
Okay.
Oh, I think I was on mute for some reason.
Okay.
Yes, I was. That's my brother, I'm sorry.
All right. Great. Well, thank you, Cassidy, for that and for being the first one to try doing this online chat thing. I know it's a bit of a learning curve. So as you can see, I saw how Cassidy did it. So when your group is up, next week we have group 3 coming up, and the other group 2 that didn't do it yet, let me know. Talk to me.
Yeah, I'm ready.
Are you ready?
Yeah, I'm group 2.
Hida?
Yeah.
Okay, Hida, come on up.
Okay, so let me share this.
Is it just you, Hida, or is your group there with you, or just you?
I think it's just me.
All right, cool. Isn't this so cool?
Can you see anything?
Phone? Yeah.
I'm not sure.
Okay, I can see it.
Okay, so you can see the slide now?
Yes.
Okay, so we did ours like me and Anthony. I did it on my major, something that had to do with my major, and he did it with something that had to do with architect and dancing. So we named it Growing Up with Math. Do anyone of you remember how did they like started learning math? Or have you asked someone like preschoolers or something? I'm not like so if you ask a preschooler what did you do all day, they will definitely say like they played all day, which is true. However, like through play, they learn everything, like social things, math, science. But today we're only gonna talk about math. So one thing they learn is math, as you said. So when children are playing with blocks, they're learning about heights and sizes. And when they're lacing beads, they're not only like playing or having fun or wasting time, they're also learning or practicing their patterns and colors. And finally, when they play with magnet tiles, they enhance their ability to build and start their first steps for learning architecture if they wanted to do it when they grow up, but like they will have the base of it. So next is how is math used in architecture?
Mhm.
So this wasn't my slide, so I'm not sure if I'm gonna do good with it.
What happened to Anthony?
I don't know, I saw him when I first logged in, but he's not here anymore.
Okay.
I don't know. So I'm just gonna read it. Math is needed to calculate weight and dimensions to make sure the buildings are sturdy. And architects use college algebra, trigonometry, calculus, probability, statics, linear programming, and geometry. Architects take measurement, convert quantities, and solve equations. It also uses simple math. It uses proportions to make scale models or structures. It uses slopes or slants of a building to make the correct measurements as well. So we learn how is math used in dance. So ballet uses physics to calculate the amount of force they need to lift the person into the air. And dance uses a counting method to synchronize the dance and music to create rhythm. It uses choreography. And fashion uses math with measurement to create costumes. Tap dancing shoes need to be sewed at a certain angle in order to get the correct sounds. So that's it, I think.
Very cool. Very cool. I'll turn on the, oh, great, thank you. I will unmute everyone. Did anyone have any questions or thoughts or comments for this group? Right, if not, I will go back to muting everyone. If you guys would like to speak, go ahead and press unmute. All right. Great. Well, thank you for both groups for sharing and for being the lone person in your group to show up and to do this. And I love the way you guys talked about how math is used in the world. One, currency. Well, right now we can't travel anywhere out of the country practically, but when we're able to, one day we'll be able to, how important it is to be able to exchange rates and how we use math with that. So thank you, Cassidy, for sharing that. And then Cassidy and Diana. And then for Hida and Anthony was sharing about how math is used in preschool, how math is used in architecture, and math is used in dance. So it's all around us. Just for other future groups, letting you know you could do it the way they did it. An idea that came up for me is, how do you want to use mathematics with looking at the coronavirus, right? There's so many statistics, so many numbers, so many graphs that are out there. Maybe that's something you might be interested in researching for yourself and sharing with our group. That being said, let's talk about what is to come for our class. The lecture part is over. Chapter 6B again is due on Thursday. If you need an extension, let me know. I'm fine with that. The quiz is today. However, what I'm going to do is I'm actually going to make it an online quiz, just because I spent so much time just trying to figure out the videos. I didn't really have time to figure out how to do online quizzes yet. So that'll be my next project next time. So for now, I'm going to make it an online quiz where you're going to take it online, and I'll have the quiz open from say from Friday to Sunday. So I'm gonna have it open for 3 days just to give you guys time to kind of figure out this thing. I want to give some grace for you guys learning the material. So the quiz will be open from Friday to Sunday. I'm writing this down so I can remember what I'm saying too. So quiz is open from Friday to Sunday. You'll be able to take it an unlimited number of times. Okay, so I'm going to give you guys an unlimited number of times to do it. And then if you get something wrong, you're going to have to redo the whole test, right? So if you don't like your score, you're going to have to redo the whole test, the whole quiz. And then it'll take the best score out of all of those unlimited times that you take it. So it'll be open Friday to Sunday. And again, if you guys need any extension on chapter 6B or 6A, let me know. I just want to kind of lighten the load a little bit because I know there's so much going on. Next Monday, we are going to meet again. I'm not sure what time yet because I know my Math 140 class meets at 10 a.m. or 10:10 a.m. and the Math 130 class meets at 1 p.m. I'm going to just try to switch it back and forth one and the other to make it fair for both sides. But I'm just going to do one session for both classes because we're covering the same material. And I'll switch it from one time or the other. If you can't make it, go ahead. I'm going to record it, and that way you'll have it on there. You can look at it later. But if you can make it, great. But especially for those that are going to be presenting, communicate with me what day you would like to present and what time. So that way maybe I could just aim for that time that your group can make it. Does anyone have any questions so far? Feel free to unmute yourself and ask away.
I have a question for the quiz.
Yes, Stephanie.
You said if we miss a question, we have to do the whole quiz, or just that question that we missed?
Great question. So if you want to redo it to get a better score, you'll have to redo the whole quiz. So I know on an exam, it's only redoing the problems that you missed. But for a quiz, it'll be redoing the whole thing because the quiz is actually going to be a lot smaller than the exam itself.
Oh, okay, got it.
And it'll just give you extra practice, basically.
Okay, thank you.
You're welcome.
Is the quiz just on factoring?
The quiz is going to be on 6A and 6B. So it'll be all of chapter 6. So it'll be exponents, polynomials, and factoring and solving equations. So everything from 6A and 6B. Good question.
Sorry, there's a quiz that already popped up online that already had a time that already went up and ended at 12:45, and I noticed it had some stuff that we just learned today.
Right.
Is there any way we can extend that one?
Thanks for bringing that up, Alexis. I will go ahead and delete that quiz. It wasn't supposed to go on. So I will I'll disable it, and then I'll have it pop up on Friday and give you guys from Friday to Sunday. Does that work? Thanks for bringing that up.
Professor, I have another question.
Yes, Ivana.
Well, it's actually two. So the first question is, will the quiz be on Canvas or on Alex? And my second question is, how many questions will the quiz have?
Great. So the quiz will be on Alex. So yes, quiz will be on Alex. You just log on and it'll pop up like as if there was an exam. It'll pop up and say quiz, blah, 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 blah. In terms of how many questions, I'm not sure yet. It'll definitely be shorter than an exam. So probably half the size of an exam.
Okay, thank you.
Good question. Anything else?
So we're not able to go to college again. We just got an email today that they're closing for the end of the spring semester.
Yeah.
I still have like one DLA to do, so what we're gonna do instead of the DLAs.
Very good question, Hida. So what the Math Success Center is doing right now is they're actually working on virtual DLAs like online. So they're gonna send out more information on that. So I'm not sure how they're doing that, but they'll send out more information. So you could do it online in whatever format that they give you guys. So just hold on tight. The next one is due the next exam, so you guys still have some time. And again, I'm totally willing to be flexible with you guys if things don't work out in terms of timeline. I could push back due dates, but aim for doing the next DLA by the next exam. And how you do it, we'll find out based on what you get. Go ahead, Erica.
Oh, no, never mind.
Okay. Great questions. Any other questions?
I kind of missed when the quiz was gonna be up.
Okay, the quiz will be up Friday to Sunday this weekend. It'll be on Alex. You'll have unlimited number of chances to take it. And every time you take it, you have to do the whole quiz over. But then it'll record the best scoring exam score.
Okay, thank you.
No problem, Victor. Any other questions?
And instructor, we're still to submit the spotlight presentation?
Yes, so great question. So the spotlight presentation, I will do that like every class when I see people popping up. Keep sending them in to me and I'll have you guys, I'll show your spotlight PowerPoint on there. And then when you're there, just go ahead and do a 3-minute sharing about what you're doing. So I didn't have time to do that for this one because I was just trying to figure out the video, but once I kind of get used to all this, I'll have you guys share. And I might just message you guys ahead of time, say, hey, in the next conference call, I'm gonna have you do the spotlight.
Thank you.
Good question. Any other questions? Group 3, you guys will be up next week, so let me know. There will not be a conference session this Friday. So I'm aiming for more of like a Monday and or Wednesday, but none this Friday. So Math 140, we normally meet on Fridays, but as you can see, our Zoom sessions are going to be maybe 2 to 2.5 hours. So we won't do Fridays. And I'll write all this out too and send it out to the class in case you guys need something. Any other questions? You guys want to talk? Make sure you just unmute yourself. Okay, maybe. All right, so I am going to record this whole session and post it up for anyone that missed it, or if you guys want to rewatch it. All the videos that I showed you of the lecture themselves, I will post those up as individual lectures. Say you just wanted to learn about how to solve a quadratic equation without having to look at all the other stuff. I'll post that up as well, and I'll hopefully get that done by the end of today. Alrighty, I miss you guys already. I wish you guys luck with everything. Feel free to contact me at any time. Facebook messaging, I'm always on, so that's the best way to contact me. Or you could do slow-mo, email, or Canvas, but feel free to contact me if you guys have any questions. I want me to work on any problems that maybe you're stuck on, okay? Alrighty. Over and out.
Thank you.
You're welcome. Take care, you guys.
Bye.
Thank you, instructor. Bye.
Yes.